Math 1332, Chapter 3, Symbolic Logic, Section 4, Logical Arguments, Video 3, Determining the Validity of an Argument, the Truth Table Method. As kind of implied by the title of this video, there is another method that we're going to look at that actually does not involve truth tables. It does involve symbolic logic, though, although at one level it actually doesn't even involve that. But let's use the truth table method first, because it's the method that will always work. The other method that we'll get to works some of the times, and when it does, it's pretty easy to use. So let's start with the technique that always works. Recall that for an argument with premises P1, P2, and P3, and so on, and conclusion C, the implication for the argument is the following conditional. Again, when you're asked to write the implication for an argument, you're being asked to write P1 conjunction P2 conjunction P3 conjunction however many premises you have, implication, which is just a double line conditional, conclusion. Since we're trying to determine if the conclusion necessarily follows from the premises, we're actually trying to determine if this implication is a tautology. So this is the method that we'll use to determine if the argument is valid, to determine if the conclusion follows logically from the premises. As such, we can build the truth table for the implication and determine if it is indeed a tautology, from which we conclude that the argument is valid. Oh, just a reminder, a tautology is a statement that is always true, regardless of the truth values of the simple statements it's built upon. So in short, we're going to do a truth table. If it comes out all true in the last column, then the argument is valid. And that is the truth table method. All right, so for our first example, we're going to determine if the argument is valid using the truth table method. Our first premise is P pointed to Q. Our second premise is just Q, and our conclusion is just P. Now, you may recognize this symbolically represented argument from the previous video because it's the symbolic representation of the following argument. Premise 1, if I get a pay raise at work, then I will take my family on vacation. Premise 2, I took my family on vacation. Conclusion, I got a pay raise at work. Remember, we started this whole thing by saying that some people will conclude from these premises that I must have gotten a pay raise at work. But in the end, we'll determine whether or not that was a valid conclusion from the two premises. All right, answer. Well, first, we have to write the implication. Okay, so what's the implication going to look like? Recall that the implication is just the conjunction of the premises pointing to the conclusion. So we'll open up a parentheses for the first part of the implication for the antecedent of the implication. Our first premise is a compound statement, so it will go in parentheses. P pointing to Q. Conjunction, our second premise is not a compound statement, so it does not need to go in parentheses. That's the conjunction of the premises, so we close off that parentheses. Implication, conclusion, which is P. This is the implication that we will build a truth table for. Next, construct a truth table for the implication to determine if it's a tautology. As you can tell, I've already got the truth table ready to go with the implication above it. So we haven't done a truth table lately, so let's go through all the details on this one. First, we use the hierarchy of logical connectives to determine the order in which to build the columns. We do have a set of parentheses, but inside of that, we have another set of parentheses. So we're going to start with a conditional P pointing to Q. Once we do that set of parentheses, we are not done with the outer set of parentheses because there is still a conjunction on the inside. So that conjunction and the things on both sides of it will be the second column. That concludes the big parentheses, and the only connective left on the outside of the parentheses is the implication itself. I do want to remind you that it's just a conditional. It follows the same rules. And it's our last column. Now let's populate this. I'm not going to write all the rules below. I will mention them. I may draw arrows referring to the prior columns as necessary. This one's easy. We're looking at these two columns at P pointing to Q. And the rule for conditional is it's false only when T points to F, which is here in row 2. So that is the only row where this conditional is false. Let's clean up the mess. Moving on to the next column. In the next column, we are doing the conjunction, and the rule for conjunction is it's true when all of it's true. The columns we're referring to are this column and that column, the P pointed to Q and the Q column. I'm not going to cover up the first column because it's not really in the way, but if you need to cover it up with your finger, writing utensil, or whatever, so that it looks something like this, then that's what you do. All right, so we're going to do the conjunction rule on the two columns that currently have arrows pointing to them. True when it's all true. That would be the second row and the third row. The rest is false. Let's clean this up. All right, let's move on to the last column. The last column is the implication, which again is just a conditional, so it follows the same rule. It's false when T points to F. On this one, I am going to cover some things up because the two columns that we need to refer to on the left of the implication is all of this, which is the column we just did. But on the right is just statement P, which is clear over here. We got all this stuff in the middle obstructing our view, so I'm going to cover it up for now. And to make matters more interesting, the implication is going left to right, but the columns are going right to left. In other words, we need the conjunction of the premises, which is this column, pointing to the conclusion. So we have to point from right to left. And play out the rule for conditional, because after all, an implication is just a conditional on steroids. The rule for conditional is false when T points to F. Are there any rows where T is pointing to F? There is precisely one, and it is this third row. T is pointing to F. Because T is pointing to F there, that means that this row is false in the last column. It's the only T pointing to F. So it's the only false in that column. We've completed the truth table for the implication. And remember, we're trying to answer the question, is this implication a tautology? Is the last column all true? It is not. Since the implication is not a tautology, the argument is invalid. Forgot what's under here. The conclusion cannot be drawn from the premise because there exists a scenario where the premises are true, but the conclusion is false, which is the broken promise. If this, then that, if the first thing happens, the conclusion is supposed to follow. In order to see that, let's get rid of this big blue rectangle there. And if you'll notice, in this row and in this row only, we have both premises are true, which makes their conjunction true, which makes the antecedent over here true, but the conclusion is false. So there exists a scenario where the premises are true, but the conclusion does not follow. The premise where P is false and Q is true. Remember that P was I get a pay raise and Q is I take my family on vacation. So if I don't get a raise and I take my family on vacation, then the first premise is true, didn't break my promise. Second premise is true, but the conclusion is false. The argument is invalid. You cannot conclude that I got a pay raise from work. And again, a lot of people will look at these two premises. Hey, John, if I get a pay raise, then I'll take my family on vacation. Later, John realizes I took my family on vacation. John concludes I got a pay raise. I did not, because it's an invalid argument. We're going to take a look at one more. And this is the other argument that was from the previous video, where all we did was write the implication. So let me remind you how it goes. The argument for this one that we're going to determine its validity has three premises. Premise 1, P if and only if Q, the biconditional. Premise 2, Q if and only if R, another biconditional. Premise 3, negation of R. Conclusion, negation of P. Now, this did not stem from a word problem context, but there could have been a word problem context. I will get married if and only if I get a raise at work. I will get a raise at work if and only if I go on vacation. I did not go on vacation, therefore I did not get married. Now, can you make that conclusion? Well, we don't have to guess. We fill out the table. At the end, if it's a tautology, then the conclusion is valid. We did write the implication for this in the previous video. It was the conjunction of the three premises. There's premise 1, conjunction, premise 2, conjunction, premise 3, pointing to the conclusion. I'm not going to write first, second, third, fourth, and fifth. I will just describe them and then unveil the columns. Going inside the parentheses around the antecedent, in other words, the first yellow box here, there are more parentheses, so we go inside the first one and we do that biconditional first. There's another small parentheses inside the big parentheses, the other biconditional. And in the big parentheses, inside the big parentheses, we're done with the little parentheses, but we still have this conjunction, that's not supposed to happen. We still have this conjunction, and this negation. Well, we know negation precedes conjunctions, so it shouldn't surprise you that the negation is next. That leaves the two conjunctions. Now, we can do one column for the first and then one column for the second, but when you have what I call a run-on conjunction, this and this and this and this, there's no need to do a separate column for each conjunction. We can just do one column for all of them collectively, because the rule for conjunction doesn't care how many statements you have. The rule for conjunction is I'm true if all parts of me are true. So we can do two conjunctions in one column using the conjunction rule. That will finish everything to the left of the implication, to the left of the double-lined arrow. On the right side is negation P, so we would do that. And then lastly, the implication. All right. Because this has three simple statements, P, Q, and R, this does have 8 rows, and I already have the truth values populated. Let's begin. All right. Biconditional. I invite you to pause the video and try to do this table. You're always welcome to pause the video and try to do something before I do, because I'm about to blaze through this. The biconditional refers to columns P and Q, which are these two, which means we need to look at those two columns and do the biconditional rule. The biconditional rule is it's true when both halves are the same. So in other words, it's true when it's true, true, or false, false. So looking in these two columns, where is it true, true, or false, false? Answer, first row, second row, not the third or fourth or fifth or sixth, but the 7th and 8th rows. Those are the rows that follow the rule for biconditional, which says true when both halves match. So those are the only rows where we write true. The rest we write false. There's 2 more trues down here. Let me clean this up. Moving on to the next column. It's the exact same connective. It's a biconditional. but this time it's referring to columns Q and R. So looking at those two columns, we apply the biconditional rule, which is true when both halves match. So in the highlighted columns, in which rows are the truth values the same? Row 1, not 2, not 3, not 4. Row 5, not 6, not 7. Row 8, I missed one. I missed one because I realized that column R has a mistake. 1 second. It's not letting me into the text box. I'm going to pause and fix this. Did you see where the mistake was? If not, then back up the video and look at it, and then look at it now. But the mistake was in the 4th row. Well, I just gave it away because the mistake was right here. I had T instead of F. Excuse me. But it has been corrected. And this is the 4th row in which the truth values match for Q and R. So that's the 4th row in which the biconditional is going to be true. I'm going to pause the video and populate this current column. I also cleaned up the table and drew a horizontal line between the top and bottom halves of the truth table just for organizational purposes. All right, moving to the next column. The next column is the negation of R. That's easy. We look at the R column and we simply change all the truth values. So instead of TF, 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 it will alternate, but starting with F. FT, 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 and it'll look something like this. Did it not pause? Oh, there we go. All right. Yes, it's looking a little sloppy, but I had to make the font size smaller to get the whole table to fit on the screen. All right, so now we're on the next column. We are on the column that is the conjunction of all the premises. And as I mentioned earlier, when you're doing a multiple conjunction, you can do one column for all of them at the same time. Just make sure you know which prior columns to refer to. In this case, we need to refer to the P biconditional Q, which is this column, the Q biconditional R, which is this column, and the negation R. And from that, we need to apply the conjunction rule, which is true only if all of it's true. So we have to look at all the rows in here to see if any of them are all true. Do you see any row that goes T, T, T? There's only one, and it's down here. That is the only row where the current column is going to be true, because that is the only row where all the statements are true, and therefore the conditional is true. Bottom row will be true, rest will be false, and it will look like this. Next column, really, really easy. It's just the negation of P. So it's the negation of this column over here. So instead of 4 T's followed by 4 F's, it will be 4 F's followed by 4 T's and look like this. And lastly, we are on the actual implication itself, which again is just a conditional. So we need to ask ourselves, what's the antecedent? That would be this column. What's the conclusion? Excuse me, what's the consequent? That column. It's the consequent in the implication is the conclusion for the entire argument. And what rule are we applying? Well, the rule for implication, which is just a conditional. So the rule for conditional is it's false only when T points to F. So do you see any rows where T points to F? And if it helps, you can draw the arrows from the antecedent to the consequent. Are we going to find any rows where T points to F? Well, there's only one row that even begins with T. It's down here, but it doesn't point to F. So the only one that could have been a broken promise ended up not being it because it's the only one that starts with true. There are no broken promises. There are no T's pointing to F's. So none of these are false, which means all of them are true. So what does this mean? Well, the implication is always true. It's a tautology. Since the implication is a tautology, the argument is valid, which means if you had 3 statements that symbolically translated to these 3 premises and a conclusion that translated symbolically to that, that conclusion is valid. I can't remember the exact example I used a minute ago. I think it was, I will marry you if and only if I get a pay raise. I'll get a pay raise only if I take my family on vacation. I didn't take my family on vacation, therefore I will not marry you. That's a valid conclusion. Now remember, when you say a conclusion is valid, you're not saying the premises are true. You're saying if they were true, then you could draw this conclusion. So to summarize, to see if an argument is valid using the truth table method, you form the implication, the conjunction of the premises pointing to the conclusion. You build the truth table for that, and if it comes out all true, meaning it's a tautology, then the argument is valid and you can draw that conclusion.